Alright, so here are the pulleys. Here is the first equation. 20t plus 40 radians per second. The angular velocity of A at 3 seconds, so you can just sub in 3 to get the angular velocity of A, which is 100 radians per second. So, according to this diagram, A and B, they would have the same velocity of this pulley. So, what you can do is you can find the velocity of A using this equation, which is V is equal to WR. The radius of A was 75 millimeters, and the angular velocity was found here to get 7.5 meters per second. And because B and A have the same velocity, you can just sub this in for VB and use the equation and just solve for the angular velocity of B, which is 300 radians per second by subbing in this. So this would be the velocity, the angular velocity of this of the B disk. And second of all, then you want to find the velocity of this. So the whole B disk's velocity is 300. Then you want to find the velocity of this pulley right here to connect B and C to find the velocity of C. So you use this equation, except using the whole radius, which would be 100 millimeters, instead of the small radius, to get a D of 30 meters per second. So this thing right here would be 30 meters per second, and that would be shared with C since it's connected there. And then you just sub that in with C's radius, which is 50 millimeters, to get a angular velocity of C of 600 radians per second, which is the angular velocity of B is 300 radians per second. There. All right. At 3 seconds. Okay. So, is this pulley design make it easier? Well, yes. Electric, that would by definition, it would definitely be easier, but would it be financially worth it to switch over? Considering you're not allowed in some cities, that would be a whole lot of money lost, as well as you have to pay for your own energy. Financially, I probably wouldn't do it, because, yeah, probably not worth it. Okay.